Hello everyone, Mike Silverman here. In this video, I'll show you how I was able to implement a rate limiter in my Express application using TypeScript and Redis, and how I was able to test that code using Jest. This is going to be a hybrid of the fixed window and the sliding window rate limiting strategies. And if you want to learn more about those, you can check out this Google Cloud article, which has a lot of good information. The specific implementation was inspired by Nakrad Mahdi's blog post from when he worked at Figma, and when he wrote this rate limiter, it actually defended against an attack by some spammers. So this strategy actually has worked in the past. Whether my implementation works or not will be yet to be determined. So how this works, I'll show you the idea of it, is every time the user makes a request, we're going to get the timestamp of a small amount of time, which we're going to call the fixed window counter or just the counter. So in this example here, every minute is the unit of time for the fixed window counter. So from 10 o'clock to 10 o'clock and 59 seconds, we could say that this user is allowed to make up to 4 requests. And if they make a fifth request before it becomes 10:01, we will deny their request. But if 10:01 comes, they're allowed to make another request, and it would just kind of keep going down like that. So this is fixed window strategy in very small increments, which means there could be a burst of traffic if at 10:59 the user makes all their 4 requests in the 10 o'clock window, and then at 10:01 and 1 second they make all their 4 requests. So you could get 8 requests right next to each other, but since we keep the number really small, it shouldn't be a problem. So then the larger limiting factor is this sliding window, which is represented by this gray bar here. So right now our sliding window is representing 5 minutes of time, but you could make it a lot longer than that. You could make it like 30 minutes or an hour. So in this sliding window, we're going to allow the user to make, for example, 10 requests. And we're just keeping the numbers small so it's easy to understand for the example. So at 10 o'clock, we go back to them making their first request. So they have now 1 out of 4 requests for 10 o'clock and the first minute of 10 o'clock. And then they have now used 9 out of their 10 requests for the sliding window. And then let's say they use 4 out of 4 here. Now they have 6 out of 10 remaining in the sliding window. And then at 10:01, they can make 1 request. We go back down, we would go to 5. And then here they can make, let's say, another 4 requests. Now they've used 9. They make 1 request here. Now they've used 10 in the sliding window. So even though it's now 10:04 and they're allowed to make 4 requests in that fixed window of 1 minute, they could not make 1 request here because they've overloaded the sliding window and they've reached their limit. Now oh man, date auto format. Now they've done, 10 out of 10 up here. But once it becomes, so they're allowed to make 0 here. But once it becomes 10:05, the sliding window will slide over. And now it's going to add up all the requests for the counters that are in its new period of time. So we don't care about these anymore, and we would delete that from our list of 1 minute fixed window counters, and that could be just gone from our memory. And now we have 5, 6, now we've got 6 out of 10 here. So the user could make a request again. They could make up to their 4 request limit here, and then that would be, they'd use up their limit for the window and their limit for 10:05 until 10:06. And once again, the time would tick by and the sliding window would move over, and then it would add up all these counters, and we would see that we have 9. We've used 9 out of 10 here. Yeah. And that's kind of how the idea works. So you have this larger limitation that is a sliding window that moves along, and then you have these little limitations here that are the counters. Okay, so let's take a look how this is implemented. Come over here. First, I create a middleware, and I have a function that creates a rate limiting middleware. And there's different options you can configure this with. So first one, you would choose how are we going to uniquely identify the user, and we could identify them by their IP address, or we could also choose to identify them by their username if they're logged in. So this one is an IP address rate limiter, so we're giving it IP address. Then the next option is some like action you want to limit. So if you want to give them a specific action to limit, you could name it anything you want. You could say like registration, and now um, you would put this rate limiter in front of your registration route, and now you're specifically limiting registration. So this is useful because for me, I want to limit registration more than just my overall routes. So this one, I don't put a specific thing. This is going to be for rate for limiting all the actions, any action. And this one is going to be just for registration. So I could put a more restrictive numbers on this, say only like 5 in an hour. Um, okay, so then the next thing you want to choose is how long do you want your sliding window to be? And I'm using 30 minutes for mine. And then the next you want to say how much do you want to allow in that time period. I think I'm using 50 here. And then you want to choose your fixed counter. How much do you want to allow in, or how small of a time period do you want your fixed counters to be? I'm using 30 seconds. And then how many requests do you want to allow within that smaller time period? I believe I'm using 10, but actually we can just go look. Yeah, I'm using 10. So I just define these constant values somewhere where I can configure how I want my application to be. And one thing to keep in mind is you wouldn't want to make this like larger than the number of requests that are allowed in the sliding window. So you want to keep it smaller. And in the original blog post, he does um, this amount divided by 60. I made mine so that you could just choose it kind of separately, but you do want to be sure that you choose the a number like too high here. If I put this at 49, for example, it wouldn't really work as well. Um, okay, so based on the mode that you choose, we come up here. This is the bottom of the function that creates the middleware. It's going to see what mode you chose. If it's user, it's going to try to get the user that we look up in a different middleware, and then we would pass the this is the unique identifier that we want to rate limit by to the function that is going to have the main business logic of this. Or the IP address. If it's the IP address, we just get the IP address from the request. Now, if you're behind a proxy, you got to do something to make sure you're not just getting your proxy's IP address. But that is kind of beyond the scope of this video. Just a note that the IP request here will just always be the same if you're behind a proxy. So you'll have to skip one proxy or however many proxies you're behind. You would have to figure that out and make sure you take care of that here. Or if your mode is global, this is going to be like if you want the total number of all requests for all users to be limited. So if I know that my application can't handle more than like, I don't know, 1 million requests in an hour, then I could limit it like that. Okay, so then it's going to return this function. So this function is going to have the main logic. So let's come up here and we'll look at that. So here we take in all of the options, the same options we passed before. Now there's two options I actually didn't show you. So this is specific options of what you want to do if the rate limit is reached. So let's say you want to send yourself an email address or send yourself an email if the limit is reached. In addition to sending them this error, then you could be notified like, hey, IP address has reached its limit. Maybe you want to go ban them or something. But right now the default is to just call the next function down the line with this error that says you're sending too many requests. Same thing for the sliding window. So this is, you can individually configure if the smaller counters is gone over or the sliding window amount is gone over. Perhaps this one would be the more concerning one that you would want to get emailed about because it's the larger limit. Okay, so you take all these options in. These are the default values that you can set if you want. You can see I'm overriding the defaults. The default here is 100, but we're setting it at 50 when we call the function down here for these two ones that we're making. And then we'll take in the request, the response, and the next function, just like all middlewares do. And you're going to want to get your Redis client. So I use a specific wrapper around Redis, and actually I have another video explaining why I do that and how I set that up. And that's so I can do concurrent tests, and my keys in the Redis store won't get like conflicting values, and I can delete them all for whenever a test is done. But anyway, just this is your store, however you connect to Redis, whatever library you use. And then you want to get the current fixed window counter timestamp. So for this was, if you look back at the example, this would be like 10 o'clock or 10:01 or 10:02. So if the actual time is like 10:00:31 seconds, then it would fall within this here. So you're not going to store the precise time. You're only going to count how many are in this window. Okay. So where are we? Right. So we'll get to find that out, we'll get the current date, and then we are going to use the modulo operator to get the remainder of the current time divided by the counter fixed window time. So it's for us, it's 30 seconds for the IP limiter. So we'll divide now by 30 seconds, and whatever the remainder is what you'll get here. And then you'll just subtract that from now. So you'll take off the extra seconds. So that would be like now 10:00:31 we would delete the 31 seconds, and now we know that we're within the 10-minute counter. Okay, so now we have our current counter interval timestamp. And then we have this function here. So this is the function that we'll call at the bottom, depending on which mode was passed in up at the top. So we'll take in our mode, we'll call it the key, and then we're going to add it to the label. So the label was your label for what action you wanted to limit. So if we pass in registration, then this would be, IP address 1.2. whatever plus registration. So this would be that IP address's number of registration attempts within the time frame. Or, at the same time, you could also just limit the IP address with nothing, which is what we're doing here. So the IP address in general, how many requests has it made? So we'll add those things together. It's an empty string here, so we'll just get the IP address. And now we're going to be counting how many requests were made from this IP address. Okay, so then to do that, we're going to first find out how many requests are in the current counter. The current counter would be one of these, so within 1 minute, or for us it's 30 seconds actually. To do that, we're going to use the h-increby, so we're going to increment the field of a hash. The hash is going to be stored on the key of whatever, like their IP address plus whatever additional label you want it to add. And then the field in that hash is going to be the current timestamp of the fixed window interval. And if you look at h-increby on the Redis website, what this does is, well, it's going to increment one of the fields of your hash, and it's going to return the number that it was incremented by. So it returns the value of the field that you incremented. So then you'll know how many requests are in that current fixed window. And let's see. Yeah, you have to pass it as a string. So Redis is storing things in strings, and we want to increment it by 1 because we just made 1 request. So once we're going to use this number to determine if they have gone over their fixed window limit. So back in this example, we were saying we don't want you to go beyond 4. So if they increment it and now it's 5, we would still record that it's 5, and we would know that this number is greater than our limit, and we would do whatever we want to do when the counter limit is reached, which by default is send them an error. That's 429 is the too many requests code, and we would say, like, hey, slow it down. Okay, but before we do that, before we return away this function and do nothing else, we also want to set the expiration of the entire hash. So we're going to expire their key of the hash, which is their IP address plus the label, and it has to be in seconds. So we have the number stored in milliseconds. We'll divide it by 1 second, which is 1,000 milliseconds. So we'll get the number in seconds, and we will set this to expire. So automatically, Redis, after one sliding Windows amount, if they haven't done anything else, if they haven't made any more requests, they'll just delete their whole hash and just free up some memory. And if that user comes back and they want to make another request, then the first thing that we'll do in Redis is increment some field. So this will automatically also create the hash with this key if it doesn't exist. So we don't have to worry about like separately creating it. Okay, but let's say they make their request and this is not beyond the current counter. So now we have to think about the sliding window. So they're okay within the small amount of time that we have limited them. But what about the sliding window? So then to do that, we have to figure out how many requests have they made within the sliding window. To do that, we have to get all of the keys in, or all of the fields in the hash stored by their IP address. So we'll call that sliding window counters, which is all of the counters for each minute or for each 30 seconds or whatever you set it at. And we'll say hgetAll. So hgetAll just gets you all the fields and values of the hash. So this will return us something like a list of all of these things. And then we can just add up their values of their fields. So we'll call a number, we'll declare a number, a variable called the total requests in the window. And when Redis stores a hash, and let's say you're like adding more fields to that hash, it doesn't necessarily remember what order you store them to, so we have to sort this out. So we'll take object entries, which just gives you an array of all the keys and values. So it'd be the key would be the timestamp of the counter, the value would be how many requests were made within that timestamp, and we'll just sort them out by their by the first element of the array. This is array of two array or an array of arrays that have two values, which is the key and the value. The first element of that array would be the key, which would be the timestamp, and we'll sort them by timestamp. So now you have a list from oldest to newest of your counters. So why do we care what order them in if we're just adding them up? Well, we're not just going to add up how many requests. We also want to remove any counter that is now too old, that is beyond the sliding window's time frame. So we are going to do that. So let's not worry about this line for the moment. We're just going to think about counting our request of all of our counters and deleting the old counters. So first we have a for loop. We're going to loop through all of the counters, so the length of how many counters we got back. And each time we go through the loop, we're going to extract the key, which is the timestamp, and the value, which is the number of requests. And we are going to say that this timestamp as a number we're just going to parse integer. So the key is always a string in Redis, so we want it to be a number so we can do subtraction and addition and stuff. So we parse int base 10, and we'll get it as a number. So now we need to find out before we add this counter's number of requests, we need to find out if this counter is even relevant to us anymore, or if the sliding window has passed it by and we don't care about the requests made in that time because they're too long ago. So we'll take the current time and we'll minus it from the window, which would be our sliding window, or a different version of it, which we'll get to. But for now, just imagine this is the sliding window time. And we'll say, is that greater than or equal to the counter timestamp? So if more time has passed, if one window's time ago in the past is a higher number of time than the counter, that means this counter is too old. So we'll delete the counter. And to do that, you can use hdel, which just deletes the field of a hash, and then that will be deleted. So now it's deleted, we won't count it up. So otherwise, if this counter is within our sliding window, we are going to find out how many requests were made in this counter, once again, it's all stored in strings, so you have to parse it out to a number. And then we'll add to our total up here the number of requests that were in that counter. And now we'll be able to break out of the loop early if we've reached the limit, otherwise we'll keep counting. So we'll check, okay, have we gone beyond our number of requests in the sliding limit? If we have, then we'll do whatever we want to do, which by default is send them this error message. Okay, so but what about this line up here? We said we would get back to that. So there is this um, like I was not call it an edge case, but since time is being counted in these increments, if you move the sliding window, it's not moving like by the precisest amount. So let's say you go from 10 o'clock to 10:01, but your first request was actually made at 10:01 and 25 seconds, then you would really want to count requests that were here from 10:00 and 35 seconds onward, but you can't because we don't store the precise time. So that means that you could sneak in these well, it would be four, right? You could sneak in these requests like kind of under the radar, and you would get past the sliding windows limit a little bit. So that means unless the current time at which the person made their first request was completely evenly divisible by the amount of time that each counter is, then it could be a little more lenient than you expected. So you could choose for that to be fine. You could say like, okay, I don't really care if they make four more requests in every sliding window, or you could say, well, I'd rather it be a little more strict, and most of the time you would actually um, your sliding window would be more like that. It would be one counter's amount smaller than the actual sliding window unless it was perfectly divisible, and then it would be the actual amount. So you have this variation. Okay, I made that the wrong color. We'll fix it, don't worry. Great. Okay, so that's what this line of code is. We're going to say what is the actual window. So we'll say now modulo the fixed window counter the fixed window counter amount of time in milliseconds. If it's perfectly divisible, then the modulo would give 0 because modulo gives remainder. If there's 0 remainder, that means it's perfectly divisible. Then we'll use the actual sliding window time. Otherwise, make it we'll make it a little bit larger by the amount of one fixed window, and then we'll deny some extra requests, and you'll have this kind of little random amount of how lenient it will be. In the blog post, Nicrod said that can actually be helpful if people are programmatically trying to send too many requests because they won't be able to like specifically know the exact interval at which you're allowing. So that's a little bonus. You could choose if you want it to be less lenient, then you would just call this. You wouldn't even just have this. Instead of using window, you would use this calculated window. You would just use your sliding window. But I like the idea. I mean, he probably knows a lot more than me about this, so I'm going to take that guidance and make it like this. Okay, so enough about that. So now we kind of see how it works. That's the whole thing. It's not too bad. Um, but how did I test this? Because when I was making this, there's a lot of times you're working with a lot of milliseconds, and it was a little bit hard for me to know if I wrote the logic absolutely correctly. So let me just put it all back so it's all good. Save that. Okay, so we'll go over and look at this test. So this is my Jest setup. All right, so this is the wrong name. This is supposed to be rate limiter. Okay, so if I copy pasted this over. First thing we do is we're going to set the real date now. We're going to save what date now gives us, which is the actual milliseconds in that moment since 1970 and whatever. I don't remember exactly the time, but it's some kind of like 1/6 or blah, blah, something like that, right? So that's what date now usually gives you some time. Uh, the reason we need to save this is because we're going to be overwriting this to give the date that we want to make sure that we're testing the rate limiter at precise times that we choose. And then we have this function that sets the date now return value. So what we do is we take the global date now function and we will use this jest mocking functionality to make date now return the exact number of milliseconds that we tell it to, and then we'll return the milliseconds. So uh, you'll see why I wrote it like this once we get down to the test, because we're going to be keeping track of uh, the date. So we'll be able to set the return of this to some accumulator that keeps track of how many milliseconds we've gone into the future. Okay, so before all our tests, we're set up. This is general, not necessarily specific to this test, but um, we create an Express app. We get the Redis context, and we make a user in our Postgres database. Uh, yeah, this is, like I said, this is not necessarily specific to this test, but the one thing that matters is we're creating this Redis context, and that is going to be only in this test will those Redis keys, they'll get like a, a specific prepended additional string to all their keys so we can delete them later and they won't conflict with other tests that are running concurrently. Okay, so before each test, we will remove all the keys from our Redis context, which will only remove keys that were declared in this test. And we will reset the date to the real date now, which we saved up here to just be whatever date now originally gives you, which is the true date to the best of your computer's knowledge at that time. Okay, and then after all our tests, we will just delete all the keys in our Redis context. Okay, so first we want to know, we'll start small. We want to see if we truly limit the number of combined requests on all routes in a small fixed window. Actually, before I show you this, I should show you that where I actually put this middleware. So remember we created this middleware. So how did I actually put this into my app? Let's take a look at that. And forgive me while I look through the files. Here it is. Okay, so this is Express app setup. You've probably seen it a lot. Um, Basically, you just use it like a middleware, and you want to make sure that you put it before the routes that you want to limit. So I want to limit people's requests for all my routes. So I put this before I start declaring my routes. But what if you want to limit a specific route? So here in the users routes, where this is all the routes relating to users, I also have the registration IP rate limiter. So I'm more restrictive with registration, and I put some smaller numbers in here, and I just put this in the chain of middlewares for this specific route only. Now these will also be limited under the IP rate limiter, and any requests that you make here will also be included in your count of total IP. So it's not this, you don't also get like plus the amount of this. It's no more than this for registering, and any request you make to registering will also be counted for your rate limit total. Okay, so back to the test. You just need to know that so that you understand why the test is going to be working. Okay, so first I'm going to be testing a route that requires a user, so I'll get my user from Postgres, and I'll create them an access token because I'm the only routes I have in my app right now that make sense to test require authentication. And then we're going to get the current time, which is the real date now, which will give me the actual time. All right, so now I want to reach my rate limit but not go over it. So after that, I can make one that I know will be denied. So we will create this array of promises so we can later call them all concurrently, which will just be requests. And for the number of the limit, we want to go up to the limit. So we will, for each, for however much the limit is, we'll make requests and we'll push onto our array a new request. And right now we're just using the get me that would give you back your own user information. And then we'll set the cookie, which was, we created that up here. Okay, so we're just saying like, give me my user information, give me my user information as many times in a row as we're allowed to. And then we will expect, and then we'll call promise.all, which will do all of these requests as fast as they all can, like racing. You don't have to do them in order, so it'll just go a little bit faster. And then these will each return response, and we expect that all of these responses will be accepted, so they should get the 200 status code. But now we're at our limit, and we want to go beyond our limit to check if the rate limiter is working. So remember that we're limiting all the routes. So even though I just called the get me route, if I call a different route, it should still be limited. So we're going to call the delete account route. And we also provided the token because you can't delete your account without a token. And then we're going to expect that the status will be 429 because we are sending back the error message, and we're going to also expect that we will get that same error message that we are saying that we're sending too many requests too quickly. So that should be good. And then now we want to see if, so we know after this we would know that rate limiting will be enacted after a certain number of requests. But we also want to know that if you wait long enough, that you can make your request again. So now this is where we're going to jump forward in time. We're going to use some time traveling by setting the date now return value to be the current time plus the amount of time that each fixed window lasts, the small windows. So that would mean that we waited the right amount of time to make the request again. And if you remember what this does is it just changes what date now will return. So, and that will affect any code that's being used in this test environment, which would include the rate limiter. So now over here, when we get date now inside the rate limiter, it's going to be whatever we told it to be in the test. And then we say that we will make another request to the app, and it should be 200 again. So if we go over here, so I mean, this is the test. This is two different tests, but I mean, they're all passing. So let's say that we did not wait this amount of time here, then it should be failed. Yeah, so you say expected 200, we got 429, so we'd still be limited, which means we didn't wait long enough. So we put that back in, and it should be succeeding. Uh, yeah, it should be succeeding. Nice. Okay, so that's our fixed windows. That was these little guys. Each of these we know they're limiting by a small amount, but we also want to know about the sliding window to see if the sliding window is working as expected. So here we say the number of combined requests on all routes in a large sliding window is limited. So similarly, we want to get a user, we want to create them a session, and we're going to start counting how many requests are in the sliding window so we can keep track of it. And let's see. So we're going to save this for later. So we're going to say, what time did we start making requests? Because later on, we want to know how much time or what time it should be when we will be allowed to make requests again, because we're going to wait the right amount of time after this. So we need to know what time we started. So we're going to set the date now return value to be whatever date it is right now in this very moment. So basically we're saying that date now should return the real date now. But it will never, if it's called later, it will never return more than this. It will always return whatever date now was when we set this variable. Important distinction. Okay, then we're going to say the current time is this first time of first request because we haven't made our first request yet. But we're going to be using this to accumulate time as we go through the tests, and we'll be increasing this number. Okay, so then we're going to do, we want to reach our sliding window limit, but we can't do that within a fixed window time because the fixed window time counter doesn't let you make that many requests. So we'll have to make a bunch of requests, jump forward in time by a fixed window amount, make a bunch more requests, jump forward in time by uh, another fixed window account. So basically, we will be doing like maxing out all of these until we get to the limit of the window up here. Okay, so while the number of requests in this sliding window, which starts at 0, is less than the limit, we want to go all the way up to the limit, then we are going to be doing this, the following. We're going to declare this number of requests to send, and we're going to determine how many we're going to be able to send in this iteration of the loop. And to determine how many to send, you might be like, well, why don't you just send the maximum, like go each time, 4, 4, 4, or 10, 10, 10, all the way to the max. The problem would be is if your sliding window is like 10, allows 10, and you want to reach the max here, then if you went 4, 4, and then 4 here, um, you would have gone beyond your sliding window limit. You would have done 12. So we don't want to go beyond the limit yet because we want to assert exactly when that happens that we want to be on the limit. So you want to do 4, 4, 2 and be up to 10 requests, and then you'll make like one more, and then you'll assert on that request to see if you got denied. Okay, so we have to find out how many requests to send in each counter. To do that, we will find out how many requests we've already made, and then we will see if can we safely add the limit of the counter to that, and if that is less than or equal to the limit, then we will make the maximum amount of requests that you're allowed to make in a counter. Otherwise, we'll make the sliding. Then we just want to make however many are left. So however many we've already made subtracted by the limit. So we would be like however many we've already made is 8. So 10 minus 8 would be 2, and we would make 2. And then we'd be all good. Okay, so then just like before, we want to do this with use promise all, so we don't have to wait for each promise one after the other. So we will take the number of requests to send, we'll push a request onto that array, and then we will await promise all to get all the promises completed and make all those requests to be all the way up to our limit, and we should expect that each of those promises will respond with a 200 status code because we have not gone beyond the limits of either our fixed windows or our sliding window, but we're all the way up to the limit of our sliding window. And okay, and at the end of each loop, right, we have to set the date now to be one more fixed counter ahead so that each loop is actually jumping in time by the right amount so that's not getting blocked by the fixed counters. And then we'll add up how many requests we've made to our oh, right, we'll add up the number of requests to send here. But I feel like that might be a mistake. Hmm. Oh, man. Okay. Well, oh, no, because it's up here. All right, so we're totally fine. I just mixed up those two. Yeah, right. We're keeping track of it up here. Woo. All right. I was like, man, I got so far in the video. I do not want to restart. Okay. Great. So we're all good here. So we'll know how many requests were made, and that's good. So then we'll see that the number of requests out of total number allowed in the sliding window. If you look over at the test here, let's get zoomed in. Maybe not that. Okay, yeah, we can zoom in this much. So that's here. We make it to 50 out of 50 allowed requests in the sliding window. So that's just a little message to see how it's going. Helpful for debugging. Okay, so then now our next request should be over the limit. So we'll make another request. We'll increment the number of requests because we just like to keep track of that. And then we'll expect that it would be 429. And with that, we get either one of these error messages. So depending on how you configure the numbers for the counter and for the sliding window, you will either have gone over the counter, which I just call that like too quickly. Technically, they're both too quickly, but this is like too quickly in a short time. This is too many requests is going over the sliding window. So you might trip this one first because you went over the counter, or you might trip the sliding window. Just depends how long your counters are, if they are divisible evenly um, by your sliding window or not. Okay, so you'll get either one of those happened. Now we want to make sure, just like before, that we're allowed to make a request if we wait the right amount of time. So we are going to take into account the extra strictness that we put in place over here, where we said that window could be one additional fixed Windows counters amount of time more strict. And to do that, to make sure we always pass, we would say, let's set the current time to be the time of our first request, which we kept that all the way back here because we knew we would need that later, plus however long an entire sliding window would be, plus the per IP fixed window counter time to make sure that we always pass. Now, since we're using a real date at the very beginning, we can actually show how this would be a variable amount of failedness or passness. So let's delete this, and let's say that we only wait one sliding windows time. And we're going to start to see that this will sometimes pass and sometimes it will fail. So let's just do it a few times, see if we can get it to pass ever. Well, usually it will fail, but theoretically, it's possible for this to pass sometimes. Uh, like only if it was evenly divisible. So, but that's basically impossible, I guess. But to better demonstrate this, we're gonna start at a not real time. So instead of setting the date now to the real date now, let's set it to 0. So we'll have evenly divisible numbers, and we can see very exactly how this will be. So when you start at a time of 0, of course, it still passes. And if we remove this counter, I think it should pass. Yeah, so it should still pass because we have a time that's evenly divisible by our counter. Our counter's time is uh, it's like 30 seconds, I think. So, but let's say we -1 from this now. So let's see if we can get it to fail. It does fail. If you do 1 millisecond under, it will fail. Okay, so now we know that it works, that it will let it go through if it's perfectly divisible by. And it's really hard to show that if you're using a real date because the milliseconds at the end is always random and it probably will not be evenly divisible. All right, so let me put that back to this. I think I showed this. Anyway, yeah, I mean, that's pretty good. Now this should be failing. So we have to add on counter, and it should work. Should always pass here. I think the way to get it to sometimes fail is this, to like subtract half of the amount of time. Yeah, this is, I believe, yeah, so here you can get some random failures and it will be a flaky test. Okay, but we want to wait the amount of time that we will always know that it will be totally fine. Okay, so there you go. So it has some sort of variable um, allowedness to it. Then this is the last part of the test. We've been running it. It should just let you run another request. Okay, so that is the rate limiter and my implementation of the rate limiter that was in this blog post. And I will link the blog post below if you want to read more information about the reasoning behind why this was created in the way that it was. And that's basically it. So, yeah, that's all I have to say on the matter. Goodbye.